Title of the first section today is Review, Graphing, Systems. In this section, we'll graph systems of equations. Systems meaning we have two or more equations. First equation is y equals 2x minus 3. And the second equation, y equals negative 3x plus 1. Each of these equations are in slope-intercept form, or mx plus b form. So for each equation, we can find m equals and b equals. The first equation, m the slope, the number in front of x would be 2, or you can have 2 over 1. And the b, the y-intercept, the last number would be negative 3. Second equation, m the slope, would be negative 3 over 1. And b, the last number, y-intercept equals 1. Graphing both these equations or both lines on the same xy axis. The first equation, b equals negative 3, where the y-intercept is negative 3. So we'll start at negative 3 on the y-axis. The slope is 2 over 1. So from the y-intercept, we'll go up 2 spots and to the right 1 spot. Connecting both those points will be the line for the first equation. Second equation, b equals 1, where the y-intercept is 1. The slope is negative 3 over 1. So from the y-intercept, we'll go down 3 spots and to the right 1 spot, which will be just underneath of our other point. Taking those 2 points, we can connect them to get the graph for both equations. The solution, if you remember, for the graph is the point where they cross. This point will be a decimal or fraction. The x value will be to the left of positive 1 or smaller than 1, and the y value would be between negative 1 and negative 2. By graphing, we cannot find the exact answer. We'd have to solve either by substitution or elimination to figure out the exact answer. Second sets of questions and last equations for the section. First equation is y equals 2/3 x plus 1. And the second, y plus 3x equals 3. The first equation is in slope-intercept form. So we can find the slope m and the y-intercept b. The slope, number in front of x, would be 2/3. And b, the y-intercept, would be 1. The second equation is in standard form. If you want to, you can plug in zeros to find the intercepts, or we can also change this to slope-intercept form by solving for y. We can subtract 3x on both sides. So y equals, the x we'll put first, negative 3x plus 3. And now we have slope-intercept form, which we can find m and find b. M equals, number in front of x, the slope would be negative 3 over 1, and b, the y-intercept, would be 3. Taking these two slopes and these two y-intercepts, we can graph the equation for the section. The first equation, the y-intercept was 1, so putting a point at positive 1 on the y-axis. The slope of the first equation was 2/3, so we'll go 2 spots up and 3 spots to the right. Connecting those would be the line for the first equation. Second equation, we'll start at positive 3 on the y-axis. The slope is negative 3 over 1, so we'll go down 3 spots, which will be on the x-axis, and to the right 1 spot. Connecting those 2 points, we'll have the graph for the equations. Again, the solution is at the point where it crosses. In this case, again, it is a decimal or fraction. The x value would be less than 1, and the y value would be between 1 and 2. Title of the last section today is Graphing Systems of Inequalities. In this section, we'll graph systems of inequalities or two or more inequalities on the same graph. First inequalities, we have y is less than 2x plus 4. And the second inequality, y is less than or equal to negative 3 over 2x minus 3. Each of these inequalities is in slope-intercept form, or mx plus b form. So we can find m, the slope of the first inequality, which would be 2 or 2 over 1. B, the y-intercept, would be the last number, 4. Second inequality, the slope m equals negative 3 over 2. And b, the y-intercept, is equal to negative 3. Graphing, once we have the slope and y-intercept. The first inequality, the y-intercept is at 4. And the slope is 2 over 1, going up 2 spots and to the right 1 spot. This is an inequality graph. The inequality is less than. If you have an inequality that's less than, it's not equal to, that would be a dashed line instead of a solid line. Also, the shading for this graph, if y is less than the equation or the inequality, y is less than means we'll shade the bottom part of the graph. Since we'll shade two inequalities, I'll draw arrows underneath this line to represent, we'll shade the bottom of the graph. Graphing the second inequality, we'll start at negative 3. The slope is negative 3 over 2. So we'll go down 3 spots and to the right 2 spots. This inequality is less than or equal to. Since it's or equal to, we'll have a solid line that connects both points. This line again we can shade. Looking at the inequality, we have y is less than or equal to the inequality. From this line, less than means we'll shade the bottom. And again, I'll put arrows on the line to represent the bottom. The answer to the graph is the part that's shaded in common. If we're shading below the first line and also below the second line, this bottom part of the graph would be the area that's shaded in common. So I'll shade this section, or if you shade both sections, you can shade this part in darker. And that would be the answer to the graph. Second question and second set of inequalities. First inequality, we have y is less than 2x plus 4. And the second inequality, 2x minus y is less than or equal to 4. The first inequality is slope-intercept form. The slope m equals 2 over 1, and b, the y-intercept, is equal to 4. For the second inequality in standard form, you could plug zeros in to solve for the intercepts, or if you solve for y, we can put the inequality in slope-intercept form. First step, we can subtract 2x on both sides. So we'll have negative y is less than or equal to negative 2x plus 4. And to get a positive y, we can divide by negative 1 on both sides. Keep in mind for inequalities, if you divide by any negative number, the inequality will flip. Less than or equal to will become greater than or equal to. Negative 2 divided by negative 1 would be a positive 2x, and 4 divided by negative 1 would be a minus 4. The slope, m, number in front of x, would be 2 or 2 over 1, and the y value, or the y-intercept, b, would be negative 4. Once we have both the slope and the y-intercept, we can graph each equation. Drawing the xy axis. The first inequality we had, the y-intercept was 4, starting on the y-axis at positive 4. And the slope was also 2 over 1, so we'll go up 2 spots and to the right 1 spot. This inequality was less than. If it's less than without the or equal to sign, this would be a dashed inequality. And the shading again, y is less than. Less than means we'll shade the bottom part of the graph, or you can draw arrows to represent the direction that will be shaded. Second inequality, b, or the y-intercept, is negative 4. And m, the slope, is 2 over 1. So we'll go up 2 spots and to the right 1 spot. This inequality was originally less than or equal to, which means we'll have a solid line for the graph. These lines are also parallel since they have the same slope. For the shading, the inequality that we solved, y is greater than or equal to the inequality. Greater than or equal to means we'll shade above this line, or again we can draw arrows to represent the area that we'll shade. The common area or solution to the graph, if we have to shade below the first line and above the second line, the common area that's shaded would be the part in between the lines. And again, you can shade underneath the whole line, above the second line, and in between the lines you can shade darker to represent the solution.